The UPAC is the International Union of Pure and Applied Chemistry. It is an international scientific organization, not affiliated with any government. Serves to advise the worldwide aspects of the chemical sciences and to contribute to the application of chemistry in the service of mankind. It can address many global issues involving the chemical sciences. It's really important to define rules to name hydrocarbons because every part of the name means something. The base part of the name reflects the number of carbons in what you have assigned to be the parent chain. The suffix of the name reflects the type of functional group present on or within the parent chain. Other groups which are attached to the parent chain are called substituents. Just to mention a few examples of hydrocarbons, we have ethane, methane, butane, hexane, and heptane. But what is a hydrocarbon? A hydrocarbon is an organic compound made of nothing more than carbons and hydrogens. It is possible for double or triple bonds to form between carbon atoms and even for structures such as rings to form. Based on the type of bonds, there are four types of carbohydrates: alkanes, which are organic compounds that consist entirely of single-bonded carbon and hydrogen atoms, and like any other functional groups. Alkanes have the general formula CnH2n plus 2. Alkenes. They contain at least one double bond. They are called unsaturated hydrocarbon. The first three are gases, next 14 are liquids, and higher are solids. Their general molecular formula is CnH2n. Alkynes. They contain at least one triple bond. They are called unsaturated hydrocarbon. The first three are gases, next 8 are liquids, and higher are solids. Their general molecular formula is CnH2n-2. Aromatic hydrocarbons. They are planar ring structures with alternating single and double bonds.
Alkanes are a class of hydrocarbons in which the atoms are connected by single bonds. One of the most common uses of alkanes is in foods. For naming these hydrocarbons, first we need to write the alkane name of the longest chain of hydrocarbon atoms. In this alkane, the chain has 5 hydrocarbon atoms, so it's a pentane. Second, number the carbon atoms starting from the end near at a substituent. Number the chain from 1 to 5 starting at the end near to the branch of CH3. Once you start numbering, continue in that same direction. Third, give the location and name of each substituent, alphanumeric order, as a prefix to the name of the main chain. Place the hyperlink between the number and the substituent name. Check what you have got. In this and the last sample, we can see that we had chlorine at the end of the chain, but we won't count it. We will count cyclic hydrocarbons, but we will count it as 1 chloro at the beginning. So when we start counting, we can see that we have 6 hydrocarbons atom, and we have a methyl in the second and fourth atom of hydrocarbon. We start counting by the chlorine. Now we can determine that we have 1 chloro, 2 4-dimethyl, because we have 2 methyls in the second and the fourth atom of the carbon of hydrocarbon. So we can got a 1 chloro, 2 4-dimethyl hexane.
Now I'm going to show you how to draw structural formulas for alkanes. Well, in this case, we will draw an heptane. So the first thing you're gonna do is to draw the 7 carbons. 1, 2, 3, 4, 5, 6, and 7.
so we need two more. Here we have two, so we need two more. We have one, so we need three. 1, 3, and 3.
Okay, now we will to put the name. So we will to collocate the numbers 1 to 7 from the left to the right.
This is number 1, 2, 3, 4, 5, 6, and number 7.
And we can see that if the number 2 there is a methyl, and in the number 4 there is an isopropyl. And we need to count that we will to collocate in alphabetical order. So it will be
4 isopropyl. There are there, and 2 methyl. And there are 7, so it's an heptane. So the name is 4-isopropyl 2-methyl-heptane.
and then I show you how to draw a condensed structural formula for alkanes.
Okay, one example of how to draw the structural formula of an alkane is this. That is 2-methyl pentane. As we already told you, there are steps. First, you put the main chain, that is 5 carbons because of pentane. Then you put the methyl, which is in the location number 2 because here is 2. And then you put the number of carbons you need to complete the bonds that it has to the hydrogens, because here you can, as you can see, these are the standard formulas. So here it will be like CH3 because this C has 3 bonds to hydrogens. Here it has 2, 2, 2, 2, or here 3, 2, 2, 2, 3, and 3. And that's why you put here CH3. Here you don't put anything because it has a methyl. Then CH2, 2, and 3. Another example could be 2,3 dimethylbutane. First, as I already told you, you put the main chain, which is 4 carbons because of butane. Then you put the methyls, that is CH3, in the locations that here told you, 2,3, 2 and 3. And then you put the then you put the hydrogens and the subscripts that needs because of the, as I already told you, because of the bonds that it has in the standard formulas, like it's CH3, CH2, CH2, and CH3. But you don't put CH2 here in this both because you have the methyl.
Alkenes are named for their parents' alkane change with the suffix -e. And the infix number indicates the position of the double bond carbon in the chain. Examples of alkenes are ethene, propene.
Alkynes are named using the same system with suffix y and e, indicating a triple bond. An example of this can be ethene.
Aromatic compound is one that has a planar ring with 4n plus 2 p electrons when n is a non-negative integer.
The derivatives of hydrocarbons are alkyl-halides, alcohols, amines, carboxylic acids, esters, amides, aldehydes, ketones, and ethers. examples can be methanoic acid or methylpentanoic acid. Of ethers, two examples can be dimethyl ether or diethyl ether. Examples of aldehydes can be methanol or ethanol. Of ketones can be acetone or methyl ethyl ketone. Or two examples of carboxylic acids can be propanoic acids and butyric acid. And two examples of esters can be benzyl acetate or terpenyl butyrate.